Now that you've read through the hypothesis testing process, we want to give you some opportunities to practice and a reminder that you will want your formula sheet out beside you. We have the 4 different types of sentences that hopefully you numbered from a previous slide, but also just a reminder that there are only 3 options for the hypothesis test. If you are given a percent or a part out of the whole, then we know we're using the 1 prop Z test. If you are given a mu with a sigma, we know we're using the Z test. And if you are given the mu without a sigma, or possibly with an S, then we're using the T test. So let's look at our first example and work through the process. In a sample of 167 children selected randomly from one town, it is found that 37 of them suffer from asthma. At the 0.05 significance level, test the claim that the proportion of all children in the town who suffer from asthma is 11%. So we have a study, 167 children, 37 of them suffer from asthma, and now we have a claim. You always want to look for that word claim because that's where you're going to start with your hypothesis. The claim is that all of the children in town who suffer from asthma is 11%. So start with step 1, finding the hypotheses. We've practiced this, H sub 0 or the null and H sub 1 or the alternative. Both of them are dealing with P, and we know that because we have a percent. There's nowhere in the problem that it talks about a mean, so this is not going to be mu. So P, remember that the null hypothesis is always equal to, and then the other one, you're going to look for any words that have greater than or less than. Our claim says it is 11%, and is the mathematical word for equals, so 11% is 0.11. And if we don't have any other words, then we just use the opposite for the alternative, which would be not equal to, and remember we use the same number. Now we're going to need it later on, so take a moment and label which one of these is the claim. From the sentence, we know that the equal to is the claim, and we'll come back to that at the end. Real quick, left tail, right tail, or two tail. Remember that you're looking at the alternative, and so it's going to be a two tail because it is not equal to. You have a slide earlier in your notes that reminds you of the 3 options. Step 3, find the test statistic and p-value on your calculator. And remember, we have 3 options. So which calculator function are we using? Well, this one's nice and easy because if it's a p, it's 1 prop. If it's a mean, you'll have to decide between z or t, but for proportion, there's no decision. It's 1 prop. And so now we go to our calculator and press stat, arrow to the right twice to get to the tests. You notice at the top we have the z test and the t test, but then number 5 is the 1 prop z test, and those are the only 3 we're going to use, number 1, number 2, or number 5. So today we're using number 5, and if you look there, we only need to type in 3 things. I strongly recommend that you write these down on your example because as you do your homework, you're going to want to look back at these examples. And so over here to the side, I'm going to draw a little box, square, to put these things in. The first one says P sub O, and if you looked, or if you remember from your notes, that's just the number from the hypothesis. Instead of saying H sub O, they say P sub O, and so we have 0.11 for the 11%. We have an X and an N, and those are going to be the numbers from the problem, from the data. A sample of 167, 37 of them suffer from asthma, and so X is 37, N is 167. N will always be bigger. If you accidentally type them in backwards, you're going to get an error. And then the third or the fourth row down, your proportion, they just want to know what is the symbol in the alternative hypothesis. And in this case, I already have my not equal to highlighted, but again, I recommend that you write that down. So pause here if you need to, type those numbers into your calculator, And now that you've got all that data in there, you have two options, calculate or draw. You saw screenshots of this in your notes. If you press calculate, you'll get a screen that has only numbers on it. At the top, they remind you that it's not equal to 0.11. They give you a z-score, a p-score, a p-hat, and they give you back the n that you gave them. This is a perfectly fine way to do the problem. Your z-score is going to be the test statistic, and the p-value is going to be the p without the hat, and you won't need the other two things. However, notice that on this problem, the p says 4.0800817 negative 6. And we've seen scientific notation that's actually 4.08 times 10 to the negative 6th. And you can move that decimal over 6 places, 1, 2, 3, 4, 5, 6, and you'll see that even if you were rounding to 4 decimals, the answer would still be 0. That's one of the reasons why I prefer the draw function. So I'm going to go back to stat, arrow over to right, to the tests, number 5. All of our data is still there, but this time I'm going to arrow down, 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 and to the right to arrow or highlight draw. When you press draw, it's going to draw the normal curve. Sometimes it will shade in, but sometimes it's so small you don't get to see the shading. But the reason I like this version is that you only have 2 answers, and those are the 2 answers we actually need to draw our conclusion. The Z, or sometimes T, will be on the left-hand side, and the P will be on the right-hand side of your screen, and that is all we need. So, I prefer the draw. If you just did it right now and you got an error, you might reset your calculator or contact your teacher for how you can get it in the right setting. So, if we continue on with our slide, we need the test statistic, which will always be a z-score or a t-score. This one ended up being 4.61. It's still almost always just 2 decimals. And then the p-value, if you noticed, was not the scientific notation. They went ahead and rounded it to 0. And oftentimes that happens where it's easier. So p is 0. Now we need alpha, and if you're having a hard time remembering that symbol, you might write the word out. Alpha is the other name for significance level. So when we go back and look in our problem, we find the word significance level, and it said 0.05. It will always be given to you in the problem, so you don't have to do anything except read and find it. And then your note said our final step is to compare P versus alpha. And that's why we've written them here on your screen so that you can see them side by side. The only thing you have to do is decide if P is less than or greater than alpha. And of course, in this case, 0 is less than alpha. 0 is less than 0.05. And so if you look back in your notes, if P is less than or if P is low, then the null must go. And that's a little phrase that I remember to help me know that we are going to reject the null, H sub 0, and that's what we call our decision. So on your homework, when it says make a decision, we just made it. And now that we know that we've rejected, we're going to write a conclusion statement, and stating the decision is where we're going to go to our chart. We need 2 pieces of information, the reject and the original claim. Go back to step 1 and see that your claim had the equal sign. So when we pull up your formula chart, we've already narrowed it down because option 1 said reject and option 3 says reject. So then we have to look at the claim. Option 1 says the original claim does not include equality. Option 3 says it does include equality. And if you want to write yourself a little note, equality means the equal sign. So we have chosen option 3, which means we can start our conclusion with the sentence prompt on your formula chart. There is sufficient evidence to warrant rejection of the claim, and then we can finish it off. Now, I know in your homework it's going to be multiple choice, but I'm going to take a time to actually write the sentence a few times, and then we may skip later. If you want to put number 3, you can, but the sentence says, there is sufficient evidence to warrant rejection, and you have to be careful because sometimes it says there's sufficient evidence to support, but this time it was to warrant rejection of the claim that the proportion of all children in the town who have asthma is 11%. Sometimes those are shorter sentences. This one was a little longer, but you're going to start with the sentence prompt from the chart and then finish it with the claim from the problem.